Hello, these are our solutions for Can You Do 10. These are a little bit different because there's not very many problems that I would anticipate that you didn't know how to get started on or know how to do. Mostly, we just need to go through the problems to make sure that you did all the steps and included all of the things that you needed to. I would imagine that most of you were able to solve all of these, and we're just double checking that the format is right. So that being said, I think that I am just going to show you each problem and let you pause on it and make sure that you have everything included. Now, before you hit pause, what I have written down, you have to have. There's nothing that I have on my paper that you shouldn't have. So if you're missing something, make sure that you write it in and maybe highlight it so that you know not to forget it. Because on a quiz and on a test, if you miss any of these elements, you're going to miss points. Also, you guys know I make mistakes all the time. So it is very likely that one of these answers is wrong. And if you have checked your answers and you feel confident in them, then you should trust yourself. And if you're very concerned, email me and just double check. But if we're getting different answers and you've checked your work, I probably just made some silly mistake somewhere and need to go in and fix my work. I know that that happened on Can You Do 10? Just kidding, Can You Do 9? There were two problems I think that I needed to fix because I said the wrong thing or I used the wrong number. So keep that in mind as we go through these. On number 1A, I have that an IQ score of 150 is at the 94th percentile. You probably could have rounded up to 95. You could have said 95th percentile. You could say at about. That's probably a better way to say it. An IQ score of 150 is at about the 94th percentile. You do need to have this, we want to find P of X less than 150. So like I said, anything that I have, you also have to have. 2, about 21.95% of people aged 20 to 34 have IQs between 125 and 150. Make sure that when you are labeling your X values, you are using subscripts like lower bound, upper bound. Same with your Z, you want to distinguish lower bound, upper bound. And then lastly, an individual aged 20 to 34 would have to earn 161.25 on the Wechsler Adult Intelligence Scale to qualify for a Mensa membership. So this one you had to find a Z-score and then solve for X. On all of these, it's important to note that I have listed the parameters for every single one of these curves, even though it's the same curve every single time. It's important that you guys are always labeling the things that you need. On the exam, it's very unlikely that they're going to make you do a problem like number 1. They are not going to have you do percents for the same normal distribution like this. So you would very rarely have to draw the same normal curve twice. That's why when we're going through these, I make you do it. Well, that's not why. I didn't explain why. The reason why I make you do it is so that when it counts, you know how to do it. I worry that if I'm like, oh, you only have to draw it for 1, you need the practice. So, yeah. Okay, for number 2, I have about 45.72% of Wilcox times are between 175 and 185. Notice I've done all the labeling once again. 2B, about 1.1% of Wilcox lap times take more than 2 minutes. And then part C, careful that when you're dealing with time, if you're in the fastest 3% of his laps, you want to be on the lower end of the Z-score, not the upper end. So you're actually looking for the bottom 3% of the data. So you find the Z that matches that, and then you solve. So I have a lap time of 1.71 minutes or less is necessary for Wilcox to be in the fastest 3% of all of his laps. Make sure that you have 1.71 or less. You could also use the word about here. Moving on to number 3. So in order to be a winner, X has to be greater than 4. So we want to find P, the percent of X that are greater than 4. So the probability that a tomato grown in the special soil will be a winner is about 2.28%. So the chances that it'll be a winner is about 2%. That's pretty low. So this is like the problem we had in our notes where we had to solve for the mean. We had to solve for the mean, and I messed that up, and I can see now that we're going through the solutions that I messed this one up too, because when you label this normal curve, you don't know what the standard deviation is. They're saying keep the mu at 398 and you find the standard deviation. So down here, I should adjust that. Okay, so if the mean diameter stays at 3.98 inches, what does the value of the standard deviation need to be to have 1% of lids that are too small? So I go through and solve it, and I ended up getting a sigma of 0.01. A standard deviation of about 0.01 will result in only 1% of lids that are too small to fit. Of large lids. So let's see if this makes sense. This would be 398. This would be 399, 401, 397, 396, 395. So my flag is a little bit too far over. My flag should be closer. My flag should have been a little bit closer to the 2. Okay, problem 5. Oh man, I was running out of room on these. So what percent of soldiers are outside the interval? So too small or too large and needs customized helmets. So here's all of my work. I have my lower bound, I have my upper bound. I state what I want to find. I want to find the percent less than 20 and the percent greater than 26. I find those percents and I add them. So about 0.72% of male soldiers require custom helmets. That's very, very few soldiers. That's a very small percent. If I had more room, I probably would have clearly written out. So maybe I'll do this in marker. Let me just grab a marker. I should have really written P plus Z less than -255 plus P of Z greater than 291 equals 0.0072. I should have done that instead of just drawing this line here. I didn't because my room was getting I was running out of room bad. Find the interquartile range. Man, this one was a doozy, family. So we had to use percentile and work backward. We needed to know the Z that matched the 75th percentile, and we needed to know the Z that matched the 25th percentile, because Q3 is 75% and Q1 is 25%. So that's what I have labeled on my curve here. And I got a Z of 0.67 has 25% to the left, and a Z of, negative 0.67 has 0.25 to the left, and positive 67 has 0.25 to the right. So it should make sense to you that these Z scores are the same distance from the mean, just on different sides of the mean. So then I use those Z scores to go through and find out what the actual measurement is. So I got that the upper bound is about 23.5, and the lower bound is about 22.1. So your IQR is about 1.4 inches. Make sure that you have your inches on there. So I had to use percentile to find Z, and then use Z to find the value that is Q1 and the value that is Q3. Then lastly, we are given an area of 15%, and we are asked to use that area to first find a Z and then solve for a standard deviation. So for number 6, I have alpha. I'm hoping that many of you guys are watching this before Monday, November 16th and Tuesday, November 17th, because we're going to meet on Zoom those days. So for Monday, that's a B day. If you're in 2B, you're going to meet with me at 9. And if you're in 3B, you're going to meet with me at 11. And if you're a distance learner, you are more than welcome to come to those meetings. I'm just going to check in with you, make sure that we're all on the same page, and answer any questions that you have. So hopefully you are watching this before then, so that if you have any questions on this, you can email me, or you can ask me when we're together in the Zoom. I hope that this was enough to help you with it. If it's not, like, somebody just email me and be like, we need a little bit more explanation than what you gave us. Okay, so I think that's it. I love you guys. I hope to see you on our Zoom meeting very soon.